Please like and subscribe to my channel and click the bell icon to get new video updates. Thank you.
Assalamu alaikum, dear students. Today our topic is a matrix. So what is matrix? Matrix is a set of numbers arranged in the form of rows and columns to form a rectangular array. We in matrix uh, we basically arrange numbers in the form of rows and in the form of columns. Let's suppose we have a matrix A. This is basically the name of the matrix, which is equal to 1 2 1 0, and these numbers, this arrangement is enclosed in square brackets. So this becomes a matrix as a whole. Let's suppose B is equal to 1 9 0 0 minus 2 and 3. This is also a matrix. So the arrangement of such number of the arrangement of data in the form in this form is called as a matrix. All the numbers inside the matrix uh, uh, is called entries. So 1 2 1 0 in this case are called as entries, or these are the values inside the matrix. In case of B, 1 9 0 0 minus 2 3 are called as entries. These are the entries in the matrix. Matrices are basically used in different fields and to solve different type of problems. So the first problem which basically we can solve with the help of matrices is to find the solution of linear equations. So linear equations are basically solved with techniques, algebraic techniques, but uh, matrices can be also used or is a helpful tool to find out the unknown values in linear equations. We can also use matrices to create graphs, to create statistical graphs. It can also be used to conduct scientific studies. And useful it is also useful in electrical circuits. So in electrical circuits we have different types of elements, uh, the arrangement of different types of elements. So all those elements have some mathematical values, and if to calculate the mathematical value of an unknown element, we basically use matrices. It is very helpful to calculate it. It can also be used as in quantum mechanics. Entries are basically the numbers the matrix basically composed of. So we already discussed entries that 1 2 1 0 are entries in case of A matrix, and 1 9 0 0 minus 2 3 in case of B matrix are entries. So what are rows? Rows are basically the horizontal alignment of numbers in the matrix. The horizontal alignment of numbers in the matrix. These are basically called as rows. And columns are the vertical alignment of numbers inside the matrix. In case of matrix A, this matrix consists of two rows and two columns. In case of B, the matrix consists of three rows and two columns. So here R is equal to 2 and C is equal to 2. In this case, R is equal to 3 and C is equal to 2. So R is basically the number of rows and C is basically the number of columns. Now let's move towards the types of matrices. Let's look at order of a matrix. Order of a matrix is basically the number of rows. Let's suppose A is equal to a matrix having entries 1 0 minus 1 2 3 4. Now if we want to calculate the order of this matrix, it will be equal to the number of rows by the number of columns. Number of rows in this matrix is equal to 2, while columns are 3. So, the order of this matrix written as order of A will be equal to 2 by 3. You can calculate for any matrix. The order of any matrix can be easily calculated as the number of rows by the number of columns. Now, let's move towards types of matrices. So, matrices have different types. Uh, the first type is a square matrix. Square matrix. If the number of rows of a matrix becomes equal to the number of columns, then the matrix will be called as a square matrix. For example, A is equal to 2, 5, 0, 0 minus 1, 3, 0, 4, 4. So there are 3 rows in this matrix, row number 1, row number 2, row number 3, and columns are also 3. So rows and columns are equal as both are 3, 3. So this matrix will be called as square matrix. Sorry, square matrix. The other one type which is in contrast to square matrix is rectangular matrix. If the number of rows not equal to number of columns, then such matrix will be called as rectangular matrix. Such matrix will be called as rectangular matrix. For example, A is equal to 1, 2, 3. In this matrix, total number of rows are 1 and columns is equal to 3. So, rows and columns are not equal because rows is equal to 1 and columns is equal to 3. They are not equal. That therefore this matrix will be called as rectangular matrix. Now let's before discussing other types of matrices, let's look at the general form of a matrix, and this is basically a general form of 3 by 3 matrix. Let's suppose a matrix A is equal to A11, A12, A13, A21, A22, A23, A31, A32 and A33. This is basically, I have written this as a general form because this A11 appear as A where row is the first row and the column is also column number 1. So it is written as A11. This value, this number A12 appear at row number 1 and column number 2. This A13 appeared at row number 1 and column number 3. So this is written as A13. Similarly, all the other elements are written in the same way. This number A21, A row number 2 column number 1, A22 row number 2 column number 2, A23 row number 2 column number 3. Similarly, A31, A32 and A33. Now, from this matrix we can define and explain principal diagonal. principal diagonal. Principal diagonal is basically all the numbers appeared at points A11, A22 and A33 is basically called as the elements at principal diagonal. So the principal diagonal basically composed of all the numbers having indices same. The indices of rows and columns are same. So here A11, row number 1, row number and column number 1 both are same, indices are same. Similarly here indices of row and column are same, and for this one also. So principal diagonal is principal diagonal is basically all these elements comes under principal diagonal, and principal diagonal only exists for a square matrix. So this is principal diagonal. Let's take another example. This is a matrix and the entries of the matrix are, so these elements 1, 3 and 1 is basically these elements form the principal diagonal in this matrix B. Now we are going to explain some other matrices. 0 are null matrix. If all the elements are entries are 0, the matrix will be called as zero matrix. For example, A is equal to 0, 0, 0, 0. B is equal to 0, 0, 0, 0, 0, 0. So such type of matrices are called as zero matrix. One type of matrix is diagonal matrix. A diagonal matrix is a matrix where all elements are 0 except at the principal diagonal. If in a square matrix, all elements are 0 except at principal diagonal. If in a square matrix all the elements are 0 equal to 0 except at the principal diagonal, then such type of matrix will be termed as diagonal matrix. For example, A is equal to 2, 0, 0, 3. This is a square matrix because it has two rows and two columns, and elements only are at the principal diagonal. All other elements are 0. So this is called as diagonal matrix. Let's suppose B is equal to 3, 0, 0, 0 minus 2, 1, 0, 0, 0, 4. Now in this matrix, in this square matrix, 3 by 3 matrix, all the elements are 0 except at the principal diagonal. So this matrix is called as diagonal matrix. Another type of matrix is scalar matrix. This matrix is a diagonal matrix. A diagonal matrix where the entries at principal diagonal are same. For example, A is equal to 2 0 0 0 2 0 0 0 2. So here at the principal diagonal the entries are same, which is 2. So now if the entries are same, it will be called as scalar matrix. If they are not same, it will be called as diagonal matrix only. Now this matrix is a scalar matrix as well as a diagonal matrix. Uh, one matrix which is called as identity matrix, called as identity matrix. In diagonal matrix, if all the entries at the principal diagonal are equal to 1, then it will be called as identity matrix. For example, 1 0 0 0 1 0 0 0 1, or B is equal to 1 0 0 1. Here this matrix is a diagonal matrix and it is called as an identity matrix because at the principal diagonal the only element exists is 1. Same is the case for matrix B. Now in the next lecture we will discuss transpose of a matrix along with some other types of matrix like symmetric matrix and skew symmetric matrix. Thank you. See you in next video. I hope this video will be helpful. Uh, please subscribe and like the video. Thanks.